So here we will study about the mole fractions. So what is the meaning of mole fraction? Mole fraction expresses the ratio of the number of moles of one component to the total number of moles in a mixture. So this block shows a mixture of different gases. Basically it's air, and if we have to find out the mole fraction of any particular gas, for an example gas number 1, so mole fraction x1 will be equal to number of moles of gas number 1 and divided by number of mole of total gas, and this is equal to actually partial pressure of gas and divided by the total pressure of a gas. So we can also get the partial pressure of individual gas using a mole fraction expression. So let's see one example of this type of mole fraction question. Here is one practice question. The total pressure of on the surface of Titan is 1220 millimeter Hg. The atmosphere consists of 82% nitrogen, 12% argon and 6% mole percent of methane gas. Calculate the partial pressure of each gas. So how we will calculate? So if you will see that the total is given here 82 and 12 plus 6, when you will combine all these, it's 100%. So out of 100 mole, 82 mole will be nitrogen, 12 mole of argon and 6 mole of methane will be there on the surface of Titan star. And pressure is, you can see this is more than Earth atmospheric pressure. So how we'll solve this question? So let's see. First we have to write all the information is given in the question, like total pressure is equal to 1220 millimeter Hg, and per number of mole of nitrogen is 82%, and number of moles of argon is 12%, methane is 6%, and we have to calculate the partial pressure of each one. Partial pressure of nitrogen, partial pressure of argon, partial pressure of methane gas. So again we will utilize this equation as we have just seen in case of partial pressure and mole fraction expression. P1 over T1 is equal to small n1 and T1. So if we are going to calculate the partial pressure of nitrogen gas, so we will modify this equation like partial pressure of nitrogen gas will be mole of nitrogen, total pressure of gaseous mixture, and mole total mole of air, all the gases. So here is 82 mole, or basically 82 we can write like this one, and then total number of mole will be 100 when you will combine all these, and then multiplied by total pressure. So this will come 1000.4 millimeter Hg. Next is and you can also convert this into atmospheric pressure, but here they are not asking in any desired unit. So millimeter Hg is given, so we can write the answer also in millimeter Hg. And argon, for argon will be that argon gas will be 12 mole percent and then divided by 100 total, and then total pressure. So this will come 146.4. and third one is methane gas, 6 multiplied by 12,000, 6 mole percent divided by 1000 multiplied by total pressure, so it will be 73.2. So this way we can utilize the mole fraction and calculate the partial pressure of each gas if we know the mole fraction of any gas in the mixture. So this was the one practice problem. Another is one more, which is a little different than this question. According to this question, they said strike anywhere matches contain the compound tetraphosphorus trisulfide, which burn to form tetraphosphorus decaoxide and sulfur dioxide gas. How many ml of sulfur dioxide measured at 725 torr and 32 degrees Celsius can be produced from burning 0.8 gram of tetraphosphorus trisulfide? So how we'll solve this question? So basically you can see this question is little tricky, it's not easy. First you have to draw the chemical reaction which is occurring between the tetraphosphorus trisulfide and it is burning. So basically burning means like we need oxygen gas, and then it is forming tetraphosphorus decaoxide and sulfur dioxide gas. So first we have to write this chemical equation and then balance it. So these two are the first two steps, and then you can see they have given a 0.8 gram of tetraphosphorus trisulfide was used. And if you will see the mole ratio from the reactant and the product side, so 1 mole of tetraphosphorus trisulfide gives 3 mole of sulfur dioxide gas. So basically we are seeing these two only because we have to calculate the pressure volume in the milliliter. So we have to calculate the volume of sulfur dioxide gas, how much volume of sulfur dioxide gas will release from when 0.8 gram of tetraphosphorus sulfide will burn. So first we have to convert that how many these gram will give how many mole of the sulfur dioxide gas. So what to do, sulfur, this is tetraphosphorus trisulfide is 0.8 gram, which we have to convert into mole by dividing the 1 mole and its molar mass. So here I calculated the molar mass of tetraphosphorus trisulfide. Phosphorus is 31 multiplied by 4 and sulfur is 32 multiplied by 3. So total is 220 gram per mole. So once you will know that how many, since 1 mole of reagent is giving 3 mole of sulfur dioxide gas, so whatever the number of mole will come here, we have to multiply by 3, then we will get the answer for how much mole of sulfur dioxide gas is coming. So once you will solve this one, it is coming at 0.011 mole of sulfur dioxide gas will came out. So from this equation we get the answer that number of mole of gas is given 0.11 mole, and then pressure is given, weight of tetraphosphorus and trisulfide is given, temperature is 32 degrees Celsius. So now we can start writing our equation. PV is equal to small n RT, and then volume they are asking, so volume will be small n RT over P, and we can add or just add all these values into equation. Volume will be 0.011 mole multiplied by gas constant and 32 degrees Celsius plus 273, this will become Kelvin. And then since they have given pressure into 725 torr, so we have to convert into atmosphere. So 1 atmosphere divided by 760 torr, and then we can place all the numbers on left hand side and all the units on the right hand side, and then multiply and then divide with this one. So answer, basically this volume is in the gas ideal gas equation express comes in the liter, so we will get the answer in the liter, which is 0.28872 liter. And then once, but they are asking how many milliliters, so we have to multiply by 1000, and then we'll get the answer in milliliters, that how much sulfur dioxide gas in the milliliter will be formed. So this is the way you can calculate the volume of sulfur dioxide gas if indirectly is not given. So you have to write, this is kind of tricky question, you have to write first chemical reaction, then balance it, then convert how many mole of sulfur dioxide you will get it from this reagents. Okay, so in next video we will study about the kinetic molecular theory. So let's